Okay folks, we're going to finish off this chapter as well as the half term with distance, speed and time. So essentially all we're doing is manipulating a single formula, and that's this one here, that speed is distance divided by time. I probably find this better to work with as a formula triangle. So we've got here distance is speed times time. If you cover up one of the things that you're trying to find, it tells you how to find it. So if I cover up distance, it tells me to do speed times time. If I covered up speed, it would tell me to do distance divided by time. If I covered up time, it would tell me to do distance divided by speed. Quite a useful thing to use. Let's have a look at some basic examples. We start with a bus traveling 222 miles in 6 hours, average speed. So if we want to find speed, that's distance divided by time. That's 222 divided by 6. That's a 37 miles per hour bus. The other thing to be careful of, obviously, is going to be units. It's miles per hour because it mentions miles and it mentions hours. Another one, Tom drives 130 miles at 40 miles per hour. How long does it take? So that's time we want to find. That's distance divided by speed. So that's 130 over 40, 13 over 4, which is 4.25 hours. Now I know it's hours because the units of speed are per hour. You might want to put that in terms of hours and minutes. Now we're going to come into this in a little bit, but don't put this as 4 hours 25 minutes. It's 4¼ hours, which is 4 hours 15 minutes. Last question, a jet flying at 484 miles per hour for 6 hours. So we want to know distance this time. So if we cover up distance, that tells us to do speed times time, s times t. So we're going to do 484 times 6, which gives us 2,904, and again, miles, because we've got that in the units of our speed. So that's the basic idea. Now, as I mentioned on question 2 there, one of the things that people get wrong, even if they do know the formula, is converting their times, because they'll see something like 4.2 hours and they'll change it to 4 hours 2 minutes or 4 hours 20 minutes. Have to bear in mind this general idea that obviously there's 60 minutes in an hour and 60 seconds in a minute, and respond appropriately. So for this first question, we want to find a distance. We want to find how far this car travels. Distance is speed times time. Speed is 45, that's fair enough. Time, 4 hours 20. So that's going to be 4 hours and 20 over 60 as the fraction that's left over, which simplifies to 4 1/3. So we're going to multiply this by 4 1/3, which gives us a total of 195 miles that it's covered. Second question, we've got here train traveling at 7 p.m, traveling 200 miles at an average speed of 70. So we want to know time. Time is equal to distance divided by speed, according to our triangle. So we want to do 200 divided by 70. No particular requirements there. And that's going to give us 2.857, etc. hours. Now we want to change this to minutes. So obviously it's going to be 2 hours and something. So I'd recommend just taking the decimal part of that, the 0.875, 14, etc. Times that up by 60, and you'll change it into minutes. That will give us 51.428 minutes, which we can, says to the nearest minute, so we can round that to 51 minutes. So overall, this journey is going to take us 2 hours and 51 minutes. Now, does that answer the question? No, because it says it sets off at 7. When does it arrive? We're going to need to add this 2 hours 51 onto it. So 7 plus 251, it's going to give us at 9:51. Specifies PM, so 9:51 PM. So that's the sort of thing I mean. People will be a bit lazy when they do those sort of conversions. Just make sure that you're thinking about times and dividing by 60. Last question we've got here. A woman running 1.5 kilometers at 12 kilometers an hour, nearest second. So we're talking about finding time again. So we want to do distance divided by speed again. So we're going to do 1.5 over 12, which is going to give us 0.125 hours. So first thing we should probably do with that is times by 60 to get it into minutes, and that will give us 7.5 minutes. Okay, that's nearly good, but we want to the nearest second. So we maybe take that 0.5 minutes, we times that up by 60, and that's going to give us another 30 seconds. So overall, she takes 7 minutes and 30 seconds. Another way you can mess up these sort of questions is with the units. We're given here meters and minutes, but we're told to answer in kilometers per hour. So you've got to be careful about how you do this. There are a couple of ways of approaching this. I'm going to go through one way on this slide and one way on the other. But here's how I look at these ones. I've got 900 meters in 1 minute. So I'm actually going to use a little bit of proportion. If I want to find out how much this bus does in an hour, and I've got what they do in 1 minute, then I need to multiply everything up by 60. So if we do that, we'll get that they actually travel 54,000 meters in 60 minutes, or in 1 hour. And then the conversion is quite straightforward. If I want to change this to kilometers per hour, well, it's 54,000 meters per hour. So that's 54 kilometers in 1 hour. And that's all I had to do there. What about the second question? Tom travels at 3 meters per second for 5 minutes. Okay, so if we want to find a distance, we need to do speed times time. This is per second and this is per minute. So what we need to do is convert them to the same. I think it's probably easiest to change this to seconds, just times it up by 60. And then we can do what we want to do. So speed times time, we want to do 3 times 300, and we can get that he covers 900 meters. Again, meters because the unit of speed was meters per second. What distance does he cover in kilometers? That's where we'll use this and divide by 1000. So that's 0.9 kilometers. Okay, lastly we've got our jet, which is traveling this far in 5 seconds and this far in 10 seconds, and we want its average speed in meters per second. So if we want an overall average speed, we need an overall, we need distance over time. So we want a total distance over a total time. We don't like work out two separate speeds and then do something with them. We just work out overall distance and overall time. Overall distance is 6 kilometers. Overall time is 15 seconds. And that's almost fine. We want meters per second though. So we're going to change this to 6,000 meters over 15 seconds. And that's going to give us 400 meters per second. Okay. So as I mentioned, there are two different ways of looking at these. I'm going to show you the other. This one's really useful when you're converting speeds. So we've got here 5 kilometers per hour, and we want to change that into meters per second. Again, we're looking at a speed, so we're talking about distance over time again. And I want you to think about, well, let's use this as our distance and our time. Our distance is 5 kilometers, and our time is 1 hour. But we don't want it in terms of kilometers and hours, we want it in terms of meters per second. So let's convert both of those. 5 kilometers, well, kilometers times 1,000 to get to meters, so that's 5,000 meters. And then 1 hour, well, there is 60 minutes in an hour, there's 60 seconds in a minute. If you times those two things together, you get that there are 3,600 seconds in 1 hour. So we actually, instead of doing 5 over 1, we're going to do 5,000 over 3,600, and it'll be in terms of the units we actually want. If we type that in, we'll get 1.3 and then tons and tons of 8s. So we might want to round that to maybe 1.39 meters per second. Okay, so you do the conversions first. What about another one? Meters per second into kilometers per hour. Again, this is a distance over time. We're talking about 15 meters over 1 second. Now, you could do this in the same way. So let's actually look at that. If we want to convert these to kilometers, we're going to have to divide by 1,000 this time. So that's 0.015 kilometers on top. Seconds, we're going to have to divide by 3,600. Now, probably it's tempting to use a decimal here, but I think that's a bad idea because the decimal is like really long and recurring. So it's best to just use the little fraction you get. If I do 1 second divided by 3,600, I just get 1 over 3,600. So that gives me the sum that I actually need to do. If I do 0.015 divided by 1 over 3,600, I will get 54 kilometers per hour. Now you might not want to do it that way. You might want to do it in a multiplication way, and we can do that like we did on the previous page. If we do 15 meters in 1 second, then if I times that by 3,600, which is again the number of seconds in an hour, I'll find out I do 54,000 meters in 1 hour. I can convert that to 54 kilometers in 1 hour, so it's 54 kilometers per hour. Either way. Last one here, we've got miles to kilometers. Now this gets given to you in the exam if they want you to use it because imperial and metric conversion is no longer on it, but I'd say it's a useful conversion to know. We've got 20 miles per hour into meters per second. Now we don't really know how to change miles into meters, so first thing we need to do is convert them to kilometers. So let's do that. If we've got 20 miles and we know that 5 miles is 8 kilometers, then that's 4 times as much. So if we think about times in the other side by 4 as well, that will give us that 20 miles is 32 kilometers. Okay, so this is 32 kilometers per hour. So let's use the trick we had before. That's 32,000 meters in 3,600 seconds. Meters, not hours. So that's the conversion we need to do. If we divide that, we'll get 8.88 ... Let's round that to 2 decimal places, say 8.89 meters per second. Yeah, useful trick, that one. Okay, we're going to finish off with 3 GCSE worded questions. I'd like you to pause the video, have a go, and then come back when you've done that. Okay, I'll assume you've done that. Let's look at this question then, which comes in 2 parts. Lee's completing a journey in 3 stages. In stage 1, he travels at 30 kilometers per hour for 45 minutes. How far does he travel? So if we want to find distance, that's speed times time, according to our triangle. So we've got a speed in terms of hours, we've got a time in terms of minutes. We need to convert this to be in hours as well. Now you can do that by dividing by 60, or you can just know that 45 minutes is 3/4 of an hour. Either way, there we go. And we're going to do speed times time here, so we're going to do 30 kilometers per hour times 3/4 of an hour. That tells us that he's traveled 22.5 miles. So if you preferred, you could have obviously written that as 0.75 hours as well. That might come in useful a little bit later. In stage 2, he travels at 50 kilometers per hour for 2 hours 48. Now again, we need to convert this to just be in terms of hours. It's obviously not 2.48. A good cheap way of doing that is just to write the 48 as a fraction out of 60. That'll work. If you might want to convert that though to a more usable decimal, and that is 2.8 hours, you might want to think about 48 out of 60 as a fraction, whatever. Anyway, we're still finding distance again, so we're going to do speed times time, which in this case is a speed of 50 times a time of 2.8, which tells us he covers 140 kilometers. Should have gone back and changed that to kilometers as well, shouldn't I? So we've got there 2 distances for the first 2 stages of the journey, stage 1, stage 2, and it says overall he travels 200 kilometers in 4 hours. So we want to figure out what's actually left at this stage. So we're going to go for distance 200, take away the 140 and take away the 22.5 that we've already worked out, and we can find that he's got 37.5 kilometers left to go in stage 3. We can do the same with the time. He's got 4 hours in total, but 0.75 hours went on stage 1, 2.8 hours went on stage 2, and then overall we've only got 0.45 hours left to go. So for his average speed in stage 3, we're going to take the 37.5, because speed is distance over time, we're going to take the 37.5 kilometers that's left, we're going to divide that by the 0.5 hours that are remaining, and we're going to find that this final stage he has to rocket along at 83 kilometers per hour. So yeah, I think decimals make this a lot easier than trying to think about it in terms of minutes. Our second question involves some speed limits. Again, I'd like you to unpause once you think you've had a go. And we're back in 3, 2, 1. Okay, so the speed limit on our road is 50 miles per hour. We travelled 19 miles in 22 minutes. Again, we want to convert the minutes, and I'd recommend leaving it as a fraction because it's quite a horrible recurring decimal. We've got 22 over 60 hours there. Is it breaking the speed limit? So we want to find its speed, so we need to do distance divided by time. Distance is 19 miles and the time is 22 over 60. If we do that division, we'll get that it's going 51.82 miles per hour. And so this is a question where you have to actually answer the question, so make sure you actually have a conclusion. Second one is this van which travels 800 meters in 45 seconds. Now there's quite a lot of conversions to do here, and it's kind of up to you when you do them. I'm going to use the second method just for a bit of change. We start off here with 800 meters, so we're talking about speed, it's distance over time. 800 meters in 45 seconds. And what I think we'll try and do is convert these to miles and hours to make that conversion. So 800 meters, that's 0.8 kilometers, that's fair enough. Remember that you have to divide by 1,000 to make meters into kilometers. 45 seconds. Now we could write that as a fraction, but I think it actually ends up being a nice decimal this time. So I'll divide it by 3,600, that's how many seconds are in an hour, and I'll get that this is 0.0125 hours. So if we do that division, we'll get that this is going at 64 kilometers per hour. But we know the speed in terms of miles per hour, so we still need to make some kind of conversion. Lots of ways you can do this. We could change this one to miles, or we could change the other one to kilometers. I'll do the second one. So it's 50 miles per hour. So let's change 50 miles into kilometers. That looks to me like a simple times by 10 situation. So 50 miles is 80 kilometers. So our speed limit is 80 kilometers per hour. So this van is not breaking the speed limit. Lots of different ways of approaching that question now. Okay, third question. Again, have a go first. Come back when you're ready. So let's go in 3, 2, 1. Okay, so we've got here a time question because we want to find the distance in time between these two journeys. Motorway and dual carriageway got different lengths, different speeds. Let's do the motorway first. So if we want to find time, we need to do distance divided by speed. Distance is 100 miles on the motorway and speed is 60. Now we can simplify that a little bit and we can get this 5/3 hours, or we could put it as a mixed number, 1 2/3 hours. But we're talking about minutes in the question, so we do need to think about actually converting it. And rather than converting it now into like hours and minutes, let's just convert it into minutes in total. We know that there are 60 minutes in an hour, so let's just times this by 60, and we'll get that this is overall 100 minutes to do this journey. And let's do the same for the dual carriageway. The dual carriageway, we again want to do distance over speed. We're going to do 80 miles this time over 50 miles per hour. That's going to give us 1.6 hours. But again, let's just change that all to minutes, and that is 96 minutes. And then answering the question becomes quite straightforward. What's the difference in time? We just need to do 100 minus 96. It's a 4-minute distance. So well worth building that motorway.